Okay, so we're going to be on the back side of your study guide. Do numbers 11 through 20. So for 11 and 12, it says evaluate the function when x equals -5, 0, and 10. So they give us the function, or the equation right here. All we have to do is plug in -5 for x, plug in 0 for x, and plug in 10 for x. So you're going to have 3 different answers for these. So I'm going to work mine out just kind of up here where I have some more room. So f of x equals 2x minus 6. So the first thing I'm going to do is I'm going to plug in a -5. So 2 times -5 minus 6. Well, 2 times -5 is -10. Minus 6 is -16. So when x is -5, that means y would be -16. Okay, now I'm going to plug in 0. So 2 times 0 minus 6, and I'm using the exact same equation. 2 times 0 is 0, minus 6 is -6. And then lastly, I'm going to plug in a positive 10. So 2 times 10 minus 6. So 2 times 10 is 20, minus 6 is 14. So we have 3 different answers here, -16, -6, and 14. And that is for number 11. Number 12, we're going to do the exact same thing. Plug in the exact same numbers. So, first of all, g of -5. So I'm going to plug in -5 into this equation. Okay, so we have -1/5 times -5, which is -5 over 1, minus 7. So on this one, I notice 2 negatives would make it a positive, and I notice I can cross cancel my 5s to be 1s. So that becomes a 1 minus 7, and you get -6. Okay, when I plug in 0, we have -1/5 times 0 minus 7 is -7. And then I'm going to plug in 10. So -1/5 times 10 over 1 minus 7. So I notice a negative and a positive will make it negative, and then I can cross cancel my 5 and my 10. So I have -2 minus 7, and that's going to equal a -9. So you have -6, -7, and -9. Okay? On number 13, it says compare the graph of g of x equals 2x plus a half to the graph of f of x equals 2x. So if you were to graph both of these equations, they're telling you to compare them. Okay? So you don't even have to graph them. The first thing you should notice right off the bat is that they both have a 2x. Okay? And if you remember, the number in front of your x is always your slope. So these lines are going to be parallel because they have the same slope. And there's their comparison. Okay, then number 14, we have, says you're packing candles in a box. You can fit 15 candles in each box. Okay, so part A says to write a linear function using function notation that represents the number of candles that you pack into X boxes. Well, if you can put 15 in every box, your equation is just going to be y equals 15x. Okay, now if they wanted in function notation, instead of the y, you would just write the f of x equals 15x. Then part B, how many boxes do you need to pack 75 candles? Well, those candles represent the y. So 75 equals 15x. Divide by 15 and you get 5 is what x equals. So you would need 5 boxes. All right, 15. says the table shows the values Y in dollars of car A and car B after X years of ownership. Which function represents a linear function? Car A, car B, both, or neither? Okay, so as we look at this table, when you're trying to figure out if it's going to be a linear function or not, you are looking for some kind of pattern. Now, the pattern that you see has to be arithmetic. It has to be addition or subtraction in your pattern, no multiplication or division. If it's any multiplication or division, it's going to be nonlinear. So let's look at car A. If you notice the value of car A, it's going down by 4,000 each year. So it is depreciating in value the same amount every single year. That's that constant pattern that you are looking for. Okay? Down 4,000 each year. Now car B goes down 12,000, and then it goes down 6,000, and then it goes down 3,000. I know that my pattern is actually dividing by 2 every time, but if you think about the value of the car, the value is not decreasing by the same amount every year. Okay, so this car B would be nonlinear, car A would be linear. So it's asking you which one represents a linear function, and that is going to be car A, because it has a constant pattern. It's going down $4,000 every single year. Okay, 16 and 17 want to know if the equation represents a linear or a nonlinear function. So back on the first page of this study guide, I don't remember what number it was, but one of them we kind of started talking about what it takes to be linear or nonlinear. Okay, so if it is going to be non-linear, probably be easier to explain this part first. For it to be non-linear, your x will have an exponent, and I want you to write this down so you have this note. X has an exponent, or is the denominator of a fraction. Okay, so if you see either one of those in your equation, it's going to be non-linear. If it's just an x by itself, no exponent, and if it's not the bottom of a fraction, then it'll be linear. So if we look at number 16, y equals 2 over x plus 1. Okay, first thing I notice is that x is the denominator of a fraction, so that's going to make it non-linear because x is the denominator. Okay, for 17, x doesn't have an exponent and it's not the bottom of a fraction, so this one will be linear. And we'll say for our explanation on this, because there is a constant slope. There's no exponent with it, and it's not the denominator of a fraction. Okay? Now, 18. The table shows the cost for theater tickets. So 2 tickets is $26, 4 tickets, we don't know. 6 tickets is $78. It says find the missing y value that makes the table represent a non-linear function. Now, I notice as I am looking at this table here, to get from 2 to 26, we would multiply by 13. Okay, to get from 6 to 78, we would also multiply by 13. So 4 times 13 would be 52. Now, if this were question mark, if that were 52, then it would be linear. So whatever number you pick for that question mark needs to be anything other than 52. Anything other than 52. So I'll just write that number in here and you can fill in If we put 52 in there, then our pattern with the y's, we'd be adding, just with the y's, we'd be actually adding 26 every time. And we don't want that constant pattern in there because we want it to be nonlinear. Okay? Now, 19 and 20. We have to write an equation, and it says for the nth term. So what that means is we could use that equation to figure out any number term in that sequence. We could use it to find the 30th term. We could use it to find the 77th term. We could use it to find the 521st term. N could be any number. But it says, and then we need to find, and it says A with a subscript of 30. That means we need to find the 30th term in this sequence. So, what we have to do here is basically create a table, like an input-output XY table, okay? 1 is your first term, 11 is your second term, 21 is your third term, 31 is your fourth term, and so on. Before we can write an equation, we have to have a slope. So keep in mind, to find your slope, we have to do y minus y over x minus x. And I'm just going to pick, again, these first two right here. So y minus y, that's 11 minus 1. X minus x is 2 minus 1. So I get 10 over 1. So my slope is 10. So I know for my equation, part of it is going to be y equals 10x. Now, if I go back up to my table, that doesn't fit the pattern here. 10 times 1 is not 1. 10 times 2 is not 11. 10 times 3 is not 21, and so on. But I'm going to use that to then figure out what other piece do I need to get to that value. Well, if I do 10 times 2, I get 20. What would I need to get from 20 back down to 11? I would have to subtract 9. 10 times 3 is 30, minus 9 is 21. So once you get that slope, your y-intercept part is just figuring out how you get back to that y value. Okay? And then we need to find the 30th term, so just plug in 30. 10 times 30 minus 9, 300 minus 9 is 291. So there's the second part there. Okay? For number 20, making a table here. Negative 15 is the first term, second term, third term, fourth term. Got to find my slope first. So subtract my y's. I have negative 15 minus a negative 10. Be careful with those negatives. And then I would have to do 1 minus 2. So this is actually going to become negative 15 plus 10, which is negative 5, over negative 1. So on this one, my slope is 5. So my equation will start out y equals 5x. Now, I need to figure out, do I need to add or subtract anything onto that to make it fit my table? So, I'm going to come over here where I have some positive numbers, make it be a little bit easier. If I plug in 4, 5 times 4 is 20. What would I need to do to get back to 0? Well, I would have to subtract 20. 5 times 3 is 15, minus 20 would give you negative 5. So you can see it checks out for each of them. And then to figure out the 30th term, we just need to plug in 30 to my new equation. 5 times 30 minus 20. So we have 150 minus 20, which is 130. And that takes you through our study guide for Chapter 5 on functions.